We are starting Unit 3 of Trig, which is trig laws. We're going to start with a section on right triangles. This is really the only day that we can presume things are going to be right triangles. And it's called SOHCAHTOA because that's what we're going to use to solve our problem. So first we're going to learn to label a triangle with the proper angles and sides. And then we're going to find missing angles and sides of right triangles using SOHCAHTOA, which is our ratio of sides. All right, this is just a review, but it has the proper labeling. Well, no, it doesn't exactly. That's the next slide, but it has some labeling. So here's our triangles, and just as a review, hopefully we know this. Here's our angles, these are our sides. So if we're looking at angle C here, our adjacent side to angle C is the side connected. The hypotenuse, of course, is always across from the right angle. And then the opposite side is the side across from that angle. And SOHCAHTOA tells us sine is opposite over hypotenuse, adjacent, or cosine adjacent over hypotenuse, tangent opposite over adjacent, and then our reciprocal functions cotangent adjacent over opposite, secant hypotenuse over adjacent, and cosecant hypotenuse over opposite. So just a little review. I think we probably know that after finishing Trig Unit 2. But now we're going to look at how we actually label the triangle for these problems, because you have to do it properly, else you're not going to be able to answer the questions correctly. So we're going to use trig ratios to find missing measures of triangles. And first of all, here's the notation. So the sides are labeled with lowercase letters. So we have our three sides A, B, C, and those are the lowercase letters. And then the angles are capital letters, so A, B, C. So a couple things to notice. Notice how it doesn't really matter necessarily how you label them, whether A is up here, well, whether A and B are interchanged. What does matter is angle C is defined to be our 90-degree angle. So I grabbed this picture from the internet and I kind of added in the right angle here. So for these problems, C will always be our 90-degree angle. And then the other thing is, notice how the associated side with the same letter is across from the angle. So side C is opposite angle C. Side B is opposite angle B, and side A is opposite angle A. So you need to understand that and know that, because if I ask you to show you a picture and ask you to find side A, and I'm telling you this is angle A, you need to know that this is the side you're going to find. So this is the standard labeling that we're going to be using. For most of this chapter, the only difference is after today, you can no longer assume that angle C is a 90-degree angle. So let's look at some examples of problems. We did some of these last year in geometry. This is kind of more of the same. It says find the missing measures, angle, angle, side. And what does this mean? This means the information you're given is an angle, angle, side. So you can see here, you always know that even if it's not marked, C is 90 degrees. So I have it marked here so you remember that at first. So we always know that C is 90 degrees. Here I told you that A is 28, and now I want to find all the missing measures, so that means we're going to have to find angle B, and we're also going to have to find sides B and A. So angle B is easy. We know triangle sum theorem, so we're going to subtract our 28 and 90 from 180 to get angle B is 62 degrees. So that one's easy. How are we going to find our missing sides? Well, we're going to use trig ratios and proportions. So we know that sine of A is opposite over hypotenuse. So we're going to put in sine of 28 degrees is equal to, our opposite is A, our hypotenuse we have. And you're going to figure out what ratio to use based on the sides that you have. Here I have hypotenuse, so that means I could use either cosine or sine along with the hypotenuse, or even, for that matter, reciprocals like cosecant or secant. But since the hypotenuse is what I have, we want to use one of the trig ratios that includes hypotenuse. So if you remember last year, we turned this into a proportion cross multiply. That gives us 15 times the sine of 28 is equal to, and these cancel out, equal to a. Multiply 15 times the sine of 28. Make sure you're in degree mode, and you're going to end up getting a is equal to 7.04. So let me write that up there. 7.04. You could actually use Pythagorean theorem at this point to find b if you wished. Since it is a right triangle, I went ahead and used the cosine. B is the adjacent side, so I set cosine of 28 degrees equal to adjacent, which is b, over my hypotenuse. Again, I cross multiply, and I'm going to find that b is equal to 15 cosine of 28, or 13.2. And now I have all my measures. Okay, next example. So in this example, the information I'm giving is a little bit different. It says find the missing measures. Notice I'm given angle, side, angle. So I don't have it marked, but we know that this is a right angle. So we know this is 90 and this is 40. And I have the adjacent side to this 40-degree angle. So that's going to determine what trig function I might want to use to solve. So again, I take my 40 and my 90, add those, and subtract from 180 to get angle B, which is 50 degrees. And now I'm going to use my trig ratios. I can use, well, adjacent, I could use tangent, cotangent, or cosine. I've chosen to use tangent. So tangent of 40 is equal to opposite, which is A, over adjacent, which is 45. And one of the reasons this using tangent, since when I cross multiply, I don't have to do another division, so it makes it nice to use tangent in this case. But either way, if you use tangent or cosine, you would find the right answer. Cross multiply, and we're going to find that A is equal to 45 tangent of 40, or 37.8. And if you have units, you would put the units there. Now I have to find my hypotenuse, and again, I could use Pythagorean theorem. So a squared plus b squared equals c squared, or I can use a trig ratio. So here are the two methods. This is Pythagorean theorem, and since it's a hypotenuse, it makes it easy, no tricks. You just square this and add it to the square of that, add them and square root them. Or I use cosine over here. So cosine of 40 is equal to adjacent over hypotenuse, which is our c. So in this case, you're going to cross multiply and get c times cosine of 40 is equal to b, and over is equal to c. I'm not sure what I did here. I want to divide. Here I need to divide out, oh, I see. Divide out my cosine of 40. So I'm going to end up with c is equal to 45 divided by the cosine of 40 and get 58.7 degrees. Either one works, and it's your choice. I won't tell you how to do the problems. In fact, by the end of this unit, you'll have multiple ways to solve this problem, and I, for the most part, don't tell you which method you should use. All right, here is a third type of problem. Find the missing measures, side, angle, side. So I have two sides here. One angle, the only angle I know is my right angle, which is C. So I can't find A and B using triangle sum. So I'm going to start finding the missing sides. Just use Pythagorean theorem. You could use trig as well. And I'm going to end up with 13. So how am I going to find the missing angles? Well, if you remember, I told you last unit, you always use inverse trig functions to find an angle. So we're going to have to use inverse trig functions here. And you have your choice because you have all your sides. So any trig function would work. So what did I use? I used sine for A. So sine of A is equal to opposite over hypotenuse. Opposite is 12. Hypotenuse is 13. So we're solving for this. So basically this means we're going to find the inverse sine of 12 over 13. And unlike before, we're mostly in degrees in this section, in this unit. So I found it in degree mode, and I got 22.6 degrees. And now I can use triangle sum. I can subtract 90 and 22.6 to get my third angle. So you're going to be using both regular and inverse trig functions in this section. All right. The last example I have, find the missing measures. I think maybe this was supposed to be for you, but I'm ending up showing you the last one you will definitely do. So here is, I use triangle sum. This is this is a 45, 45, 90. So you can go through a lot of work, but once you find this, you might notice this is isosceles, so these two sides are congruent. So it's easy to find A because it's going to be equal to B, so A is going to be 8. I also show you how you could do it with, whoops, no I didn't. This is how I'm going to find the hypotenuse. So again, I should put here, so A is equal to 8. You could use Pythagorean theorem. I use cosine, so cosine of 45 degrees is equal to adjacent over hypotenuse, cross multiply, and I'm going to get h cosine 45 equals 8, and then I'm going to divide out my cosine of 45. This cancels out, so h is 8 divided by cosine of 45, or 11.3. And as I said, you could also find Pythagorean theorem. Some people actually really like doing the trig, and they like to do it this way, but it's up to you. All right, so this last problem is one that you should try. And you have just the one angle, so you will need to figure out how to find both the missing side and the missing measures, and you should check your answers in class and bring any questions.